Hello, you are highly welcome. Into this tutorial, we are going to solve this problem here, but I believe some of us can do it. Then I would like you to pause the video, kindly do it, then come back and check our steps. So we have this: x to the power of 4 minus 625 equals 0. Now what I want us to do here is that this 625 is very big. Now can we rewrite this 625 in another form? Let's say 6, or in index form as this: 625. Let's divide 5 throughout. You can see we're going to be having 125. Then 5 divided by 125, we're going to be having, we have 125 divided by 5, we're going to be having this to be what? This to be 25. 5 divided by 5 again, we have 5 here, we have 5 here. So you can see we have 1. So which shows that if you multiply everything here, that is 5 times 5 times 5 times 5, you're going to have 625, right? So we are going to do that. So which means this is 5 to the power of 4. Okay, so we're going to have that. We have what? We have x to the power of 4 minus 5 to the power of 4 equals 0. Very interesting, because you can see the powers now the same. So now from there, the next thing we're going to do is that obviously, you know that when you put x equals 5 here, this equation will satisfy. Okay, all this left hand side must be equal to the 0, right? So but we are not looking for only one solution. We must get all the value of this, because this is quartic equation, and quartic equation that is algebra equation that has the degree of 4. Therefore you're going to be having 4 possible solutions, right? So it might be real or it might be complex. So we have to check for all the what, we have to solve for all the what possible roots, quartic, right? So now from here we're going to have this to be x. I can rewrite this as x to the power of 2 to the power of 2 minus, now here to be 5 to the power of 2, then to the power of 2 equals what? Equals 0. So now from here, what am I going to do? I can simplify this one further by having x to the power of 2 all to the power of 2 minus, this 25 can be written as 25, or 5 raised to the power of 2 can be written as 25 to the power of 2 equals 0. So we are going to apply difference of 2 squares. So from difference of 2 squares, when you have a squared minus b squared, will give us a plus b, or a minus b multiplied by a minus b. So we're going to do the same thing here. A squared minus 25, okay, a squared, x squared plus 25 equals what? Equals 0. So now from here, this is 0 form equation. So x squared minus 25 must be equal 0, could be equal 0, or x squared plus 25 could be 0. So now from here, let's now pick each of these. You know that if you transpose this to this side, we're going to have x to be 25, taking the square root plus or minus, we're going to have that x is going to be plus or minus what? 5. Then let's look at this. This is going to be x squared equals, we transpose this, we're going to have minus 25, taking the square root of both sides, we're going to have x to be plus or minus the square root of minus 25. Now for this one here, to simplify further, we're going to have x equals, now plus or minus, this one can be written as root minus 1 dot root what? Root 25. Then x equals plus or minus root of minus 1 is same thing as I, that is our imaginary number, and the square root of 25 is what? Is 5. So we have x to be plus or minus I5. So now in all, you can see that we have x1 and x2 here, and we have what? We have x3 and x4 here. So because x1 is plus 5 and x2 is minus 5, here x3 is plus I5 and x4 is minus I5, and that's the solution, okay, to this beautiful problem. So if you enjoy this class, please do not hesitate to share to your friends and family so they can learn from it. Subscribe to our YouTube channel, hit on the bell icon so that you'll be notified anytime we upload a new content. Thank you for watching. Bye bye.